Okay, so today we're going to continue looking at shifting functions. It's a tough topic to pick up at first, so we're just going to do kind of a refresher on what we did last class. We're going to focus on a couple main things, and then that way hopefully you feel a little bit more comfortable with what we did yesterday and then what we're following up with again today. So it says that we have this function f of x shown on the grid below. Second function g of x is defined by g of x equals f of x plus 2 minus 4. So here we've got this new function, and we're asked to identify the transformation. Now maybe you want to think about Hicks void here. Remember, Hicks means horizontal inside parentheses and affects the x's, vertical outside parentheses and affects the y's for void. So this plus 2 is telling us to think about Hicks. Plus 2 changes x's because it's inside parentheses, meaning that we have to do the opposite. So in this case, we're shifting left 2. Go ahead and tell me what that minus 4 on the outside is telling you to do. Write it right there on your paper and then check in with me. So we should have said down 4 because we do follow the direction of the sign in this case. So we go left 2, down 4. Remember, that means take each point, go to the left 2, and then down 4, plot it. Take the next one, left 2, down 4, plot. Left 2, down 4, plot. So on and so forth. Do this in a different color so that it stands out to you if you have colored pencils or highlighters, crayons even, anything that will separate this from the original graph. Left 2, down 4. If you have a straight edge, it's very helpful to connecting these points. Otherwise, do the best you can to make them as straight as possible. Now the next part says evaluate g of -1, g of 0, and g of -5. So remember that in each of these cases, the parentheses, like the value on the inside the parentheses, is an x value. So for the first one, we go to the left one, and we don't stop at the black graph, but we keep going all the way to our new graph. Remember, they're asking us to evaluate g. I didn't label it, we should have, but the new graph is g of x. So if I go to the left one, I'm going down 1, 2, 3, 4, 5, 6. So g of -1 equals -6. Go ahead and try the next two on your own. Oh, that noise is my cat biting my microphone, if you heard that. Alright, so I found g of 0 is -1, and g of -5 is -6. So what we're going to do now is actually a practice problem. So I'm going to tell you to go to page 2 and do number 1. So I'm going to flip there with you, but if you need more time on example 1, then just pause the video. Otherwise, open up your packet to the next page and start with number 1. It's a practice problem almost identical to what we just did. Okay, so I just want to remind you the video's gonna play a little bit awkwardly because it does one page at a time. So if you have not already gone to page 2 to do practice number 1, you need to flip there now. And I guess you're probably going to have to fast forward through the video, or you can just check it out after you do example 2. Not a huge deal. You may have to, again, fast forward through the video, probably, I don't know, 3 minutes or so until you see page 2, number 1. I guess I didn't think that through very well with the flipping back and forth. But again, try practice on the next page, number 1. Then as you're doing it, you might have to fast forward the video and then rewind afterwards, or just wait. just wait might be the easier option. Okay, so example 2 here says that we have a function whose domain is -5 less than or equal to x less than or equal to 6, and the range is -3 less than or equal to y less than or equal to 2. And it says that we're asked for the domain and range of a new function, f of x minus 3, close parentheses, minus 4. So this -3 and -4 is something that we already know how to deal with, and so I'm going to ask that you write down what is actually occurring. What's the -3 mean? What's the -4 mean? And then just check your answer with mine. So we should be moving to the right 3 and down 4. The down 4 is the easy part. That's the outside -4. -4 means move down. The inside, the -3, means to do the opposite direction, so move to the right 3. And again, if we think about a graph and we move towards the right, adding 3, moving towards the right. So we're going to add 3 plus 3 to x's. Down 4, if I go downwards, boom, 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 down 4, that means that we are subtracting 4 from the y's. So we're going to do just that in order to find our new domain and our new range. So start by writing the old one, -5 less than or equal to x less than or equal to 6. Then it said that we're going to add 3 to the x's, plus 3 to x's. So literally add 3, add 3. New domain, -5 plus 3, -2 less than or equal to x less than or equal to 6 plus 3, 9. There's the first half of our answer. Move into range. Again, start by writing the original from the problem. This time, instead of adding, we said we were going to subtract 4 from the y's. So our new range, -3 minus 4 more is -7, less than or equal to y, less than or equal to -2. There we go. That problem's done. So again, we're going to try the practice on the next page, practice problem number 2. So again, you're trying number 1 right now. Once we finish it, we're going to go back to example 2 on the front page. Remember to identify what's happening here. What's the -3 on the inside? What's the +2 on the outside? I'm going to do this up here on the screen independently, quietly, silently, so that you have a chance to practice on your own. If you need to pause the video because you feel like you might be looking up at the screen the whole time, then pause it. You're not doing yourself any good if you're just copying what I'm doing. I'm giving you a chance to practice independently, so please try. If you need more time, just pause the video. Otherwise, take a look at my answers. When you finish and you've got them perfect, go back to example 2 on the first page. Okay, so now we're looking at practice number 2. This is a domain and range question. So first, think about what's happening with this new function, and then actually apply it. Just like with the last practice problem, I'm going to do this one silently here on the screen, and then that way you can check your answers as you go or at the very end. That's my cat again. She just laid on top of the screen, so that's cool, Bets. All right. All those marks are from her. Sorry. All right, so I just finished up problem 2 for the practice. If you need more time, just pause the video. Check in with your answers with mine so that you can see whether or not you're correct. If you have questions, then of course you can rewind it, go back to the previous page where I actually explained how to do it. Whoops. Otherwise, move on with me to the next page. Okay, so we're going to do part A and part B. Part A and part B. And first, I want you to do A independently. You should not need me for this problem. Actually, it's the same problem as the other day. Okay, so skip example 3, and let's move on right here down at the bottom to the practice, starting with A and B. Hopefully you were successful in saying that the shift is left 3 and up 2. This positive 3 on the inside makes us move towards the left, and this positive 2 on the outside means move up 2. So we did a problem like this yesterday. We have a turning point initially at 0, 0, so this is where our function looks like this. Absolute value of x goes up 1 over 1 with that vertex or turning point at 0, 0. But we just said that we're moving towards the left 3 and up 2. 1, 2, 3, up 1, 2. So our new vertex or turning point is over to the left 3 and up 2. So that means I went negative 3 and positive 2. So this new turning point should be at negative 3, positive 2. Now, the reason it's working like this, where we just take the description and then make it into a point, is because we're starting at 0, 0. Cross off C, and let me say that the original is at 4, negative 2. And the transformation is right 2, up 4. So I want to know what are the coordinates of the new turning point. So to the right 2 means to add 2, up 1 means to add 4. So add 2, add 4. So the new coordinates would be 6, comma, positive 2. I'll give you another one off to the side here. Let's say the original vertex or turning point is at negative 4, positive 6. The transformation is left 4, down 3. What are the coordinates of the new? So left 4 means to subtract 4. Down 3 means to subtract 3. So we have negative 4 minus 4 more is negative 8. And 6 minus 3 is is positive 3. So again, that's just more practice with that turning point and using the shifts to describe where it's actually located. All right, so this last page is just practice. If you'd like to do this, you're welcome to do so, or if you feel comfortable, you can move on to your homework. I will put the answers up here in just a minute, so if you are going to do this, then pause your video and then check the answers when you're done. If you're not going to do it, that's fine, but stay with me for just another minute or two so that we can circle homework problems, just like we did yesterday. Okay, so if you did the practice, here's the answers. Again, if you chose to do it, you may want to pause the video before you see my answers. If not, stick with me so that I can tell you what homework problems that you should focus on. Okay, so I want you to fill in the table below just like we did yesterday. I also want you to do all of, not all of number 2. Let's do 2A, B, C. Then we're going to do number 3. So on this page again, we circled number 1, 2A, B, C, and number 3. Then we're going to flip it over and circle some more. Okay, we're going to circle number 5 and number 6, all of number 6. So on the back side, we circled 5 and 6. Remember, you can go back and rewind the video if you need to while you're working on your homework, or if you are choosing to do classwork, or you just need to go back and get a little refresher. That's fine. Remember, this video is here to help you, so utilize it in every way possible.